Okay, let's jump right into this explainer. If you've been following the AI space lately, you know we are in the middle of a massive, fundamental shift. We aren't just talking to chatbots anymore, right? We're building AI agents that can actually go out and do things. But with that incredible power comes a whole new set of headaches. Today, we're going to follow the story of a fictional company called Govern Global to understand exactly how to safely deploy agentic AI. We'll look at how they went from absolute chaos to total control, and what we can learn from their journey to secure our own AI ecosystems.
So this is the exact question that was keeping the leadership at Govern Global up at night as their AI systems evolved. Look, it's one thing when an AI drafts a slightly awkward email or maybe hallucinates a historical fact. That's annoying, but manageable. It's a completely different universe when that same AI has the keys to your production database, your CRM, or your cloud infrastructure. What happens when the helper suddenly becomes the doer? The entire risk model just flips on its head.
To understand their solution, we kind of have to look at the mess Govern Global was in to begin with. They started out like most companies, building simple, helpful chatbots. But as teams demanded more features, they hit a brutal wall. Every single new AI tool required a custom API bridge. If they wanted the AI to read Jira tickets, they had to build a connector, check Slack, build another connector. Soon, they were just drowning in custom API sprawl, and this led to a massive rise in shadow AI. Disconnected tools built by different teams with zero central visibility, incredibly weak audit logs, and skyrocketing costs. They were literally building a house of cards. To solve this integration nightmare, they discovered the Model Context Protocol, or MCP. And this fundamentally changed how their AI connected to their business. Instead of writing custom code to wire every single language model to every single internal tool, MCP provided them with an open-source standard. It's a unified architecture where an MCP host, like an AI app, talks to an MCP server that safely guards all those external data sources and tools.
The best way to think about MCP is like a universal USB-C port. Before MCP, Govern Global had the equivalent of a drawer full of tangled, proprietary charging cables. Every tool needed its own specific adapter. But the new way? Any AI application can securely plug into their CRM, their databases, their HR systems, all through one standard interface. You build an MCP server once, and any compatible AI client can use it. It makes integration infinitely scalable.
But here comes the real plot twist in our story. Because MCP made connecting tools so easy, their AI rapidly evolved from just answering questions to independently executing tasks. We crossed the line from informational AI to agentic AI. The AI wasn't just summarizing support tickets anymore. It was reading them, updating the records, and closing the cases. It wasn't just drafting an email. It was actually hitting send. And this completely changed their risk model because suddenly the AI had agency.
With agents now taking direct action, Govern Global had to confront a terrifying new reality. They had to ask, what is the potential damage of a single mistake? This is what we call the blast radius. See, when a language model only generates text, the blast radius is confined to the screen. The worst it can do is give you bad advice. But when an AI agent is wired into your enterprise systems, a hallucination or a security breach isn't just a bad answer anymore. It's a massive, system-wide event. The blast radius was no longer just a hallucinated word. If a tool isn't secured properly, an AI could literally be tricked into executing a SQL injection and dropping a production database table. We're talking about deleted customer records, unapproved financial decisions, or the exfiltration of sensitive HR data. A poorly coded tool could easily lead to resource hijacking or total system downtime. The stakes here are just incredibly high.
So, an absolutely crucial point here is understanding threats like prompt injection. Imagine your AI agent is assigned to read incoming customer support emails. Now, an attacker hides a malicious instruction in invisible text inside one of those emails. The agent reads it, gets hijacked, and instead of summarizing the issue, it follows the hidden command to export your user database. Simply reading a corrupted piece of text can turn your super helpful agent into an insider threat.
To regain control and keep innovation safe, Govern Global knew they couldn't just rely on the MCP protocol itself. Because remember, a USB-C port doesn't really care what kind of data flows through it. They had to build what they called a governed platform layer. This is essentially a centralized control room sitting directly between the AI clients and the back-end MCP servers. It ensures that every single request is intercepted, checked against policy, and logged before it is ever allowed to execute.
This architecture builds out a highly secure 6-station enterprise MCP gateway. An action doesn't just happen anymore. First, it confirms exactly who the user is. Second, it verifies the agent host to ensure it's approved. Third, the MCP client initiates the protocol. But step 4 is where the magic happens, the enterprise MCP gateway. This acts as the bouncer. It checks all your policies, enforces access rights, and then routes the request to an approved MCP server in step 5. Finally, step 6 ensures the entire interaction is permanently logged for evidence. And to enforce safety at that gateway, they classified every possible tool into a strict 5-tier action dictionary. This is brilliant for risk management. Read actions, like searching a database, just need standard logging. Write actions, like creating a ticket, might need a pilot phase. But look at the destructive tier, things like deleting files. The rule here explicitly demands a human in the loop. The AI can queue up the action, sure, but a human must click approve. And for high-impact financial decisions, the AI only assists. A human absolutely must decide. They also established rigorous release gates. Think of these like a pre-flight checklist. An agent could be instantly blocked from production if it lacked a registered owner, if its tools weren't assigned an action tier, or if it hadn't passed prompt injection testing. But most importantly, it could not go live if there wasn't a fully documented incident response path. You simply cannot deploy an agent if you don't know exactly how to pull the plug when things go wrong. Because let's face it, failures will happen. It's inevitable. So Govern Global implemented a rigid incident response chain. First, detect the anomaly. Second, contain it. Maybe you just disable the agent's write capabilities so it instantly becomes read-only. Third, preserve the evidence. This is absolutely critical. You must lock the audit logs before you try to fix the problem so you don't destroy your forensic trail. Finally, assess the damage and remediate.
And that brings us to this number, 0. That is exactly the number of unmonitored shadow AI tools running at Govern Global today. By implementing the Model Context Protocol combined with a governed platform layer, they completely eliminated the chaos. Every AI agent is visible, every tool call is logged, every destructive action requires human approval, and costs are fully transparent. They achieved the holy grail of enterprise tech, security that actually enables speed. Ultimately, Govern Global learned that while MCP makes integration infinitely scalable, strict governance is the absolute only way to make it safe. Because it really doesn't matter how smart your AI is if you can't control what it does. And that leaves us with a powerful mantra for this new agentic era. Move fast with AI innovation, but govern faster. So, as you look at your own AI deployments, I want to leave you with this provocative thought. As you give your AI systems the unprecedented power to act, are you building the engine of tomorrow with the brakes of yesterday? Think about it. Thanks for joining me on this explainer, and we'll catch you in the next one.